Okay, now we're in chapter 7. So let us think about what we're going to do there. So we had basically 3 sections. One was linear equations in one variable. So we have 3 kinds that you need to be able to solve. So I'm going to give you one that has, some multiple things that you've got to multiply out and do combine like terms and things like that. So I'm just making up a problem here. Okay, so one will have where you do have parentheses, and so the first step is to get rid of the parentheses by multiplying out the terms, being very careful if you've got negatives and the negatives that you result, do it correctly. So we're going to get all the individual terms. So 4 times 2 is 8, so that'll be 8x. 4 times 7 is 28. On the other side we have 13, which is all by itself. We have negative 2 times 4, which is negative 8. Negative 2 times negative 1, which is positive 2. Okay, so that's the first step. Then you combine like terms. So on this side we have 2 terms that have an x. So we combine those two. 3 plus 8 is 11. Then we have 28. That's just by itself. Here we have 13 and 2, which are constant terms, so we combine those two. 13 plus 2 is 15. And then we have the negative 8x. Okay, second step. Combine like terms. So I'll say remove parentheses. Second one, combine like terms. Next one is to isolate variable, which is x term. So what I want to do is I want to get x's onto the left-hand side. So let me just rewrite that because I just wrote some words in the way. So what you do is you add the additive inverse of one of the terms. You can either do this one or this one. I tend to do the one that's on the right-hand side because I want the variable to be ultimately on the left-hand side. So I look at this. What's the additive inverse of negative 8x? Well, it's positive 8x. And I have to do that to both sides. That's the additive property of equality. I want this, which is my constant term, to be to the other side. So I want to get that to disappear, so I add the additive inverse. So I add negative 28 to both sides. Then I add the two equations. So this is equal because I said it was, and this is equal because it's the same thing on both sides. So when we add that, we get 11 plus 8 is 17x. That's 0. 15 minus 28 is negative 13. And these go to 0. So you don't really have to show the zeros if you just want to go straight to this. So that's isolated the variable term. And the final thing is to have one coefficient in front of variable. So in this case, the variable is x. I mean, it could use another variable besides x, so that's why I just say the front of the variable. So you do that by using the multiplicativity, that's a word, isn't it? Multiplication equality property. It says if you multiply or divide by the same number, then the equality remains the same. Here we added the same things to both sides. Here we're dividing by the same thing. And what happens is by dividing by this number, you get 17 over 17, which is 1, which I can just leave off. It's assumed to be there, is negative 13 sevenths. And more than likely and not, this will be a fraction. I'm not going to go to any effort to try to make it to be a whole number. Now, the two other kinds of situations you're going to have is where you might have fractions. So let's say I have 1/2 x plus 7/8 is equal to 3/4 minus 1/8 x. So it's the same as the one we just did, except it's got fractions. So what you want to do, and I want you to do this or you're not going to get credit, if you just do it in terms of fractions, I'm not going to count it, multiply by a number to eliminate fractions. So there's really two ways. Now this one's a little more difficult because I did it as separate terms, but because it could multiply 2 times 8 times 4 times 8, but that would be really big. So what I may do is I'd see if there's a common, something that was common, the least common multiple. And you'd find that would be 8 because 8 divided by 2, you can divide 8 by 4, you can divide 8 by 8. So in this case, I would multiply everything by 8 every term. So I'd have 1/2 x times 8 plus 7/8 times 8 is equal to 3/4 times 8 minus 1/8 x times 8. So what I can do is, doesn't matter what order you multiply in. So I can move the 8 to here, and I can do the same thing with it in all the other cases. Well, this one's already, I don't have variables, so I can just leave it as it is. Same here. This one I could say it's -1/8 times 8 times x. And so each one of these, you can either use your calculator or you can just do it in your head. So 1/2 times 8, or 8 divided by 2 is 4, so I get 4x. Here I get 7/8 times 8, well these cancel out, and I get 7, and 3/4 times 8 would be 6. Again, you can use your calculator, or you can, 8 divided by 4 is 2, 2 times 3 is 6, and 8 times 1/8 is 1, so I get -1x. So now I just have a single equation in a single variable that has integers, and at this point I can go on it. And in this case I've already combined any terms. Well, actually I didn't need to combine any terms. So this case, the next step is to isolate the variable term. So I want to get the variable term on the left hand side. So I'm going to take the additive inverse of the variable term on the right hand side, and I'm going to take the additive inverse of the constant that's on the left hand side. Put a little equal sign in there. And then I add everything. 4x plus 1x is 5x. This is 0. This is -1. That's 0. So then I divide by the coefficient in front of the variable. I get x is equal to -1/5. Okay. And the third case is if I have decimals. So let's say I have 0.026 times x plus 7 plus 0.04 times 2x minus 3 is equal to 0.15 times x plus 1. And so I want to solve for x. So just like with the fractions, we want to eliminate the decimals. And so what you do is you look for the term in front which has the most digits to the right of the decimal point, which is this one, 1, 2, 3. This one has 2, this one has 2. So because I have 3, if I had one term to the left, I'd multiply by 10. If I have 2 terms to the left, I'd multiply it by 100. If I have 3 terms, I'd multiply by 1,000. So that's the number of digits to the right of the decimal point. In this case, and you find the one that is the most. So the one that's the most is this one. So I'm going to multiply the whole thing times 1,000 because of that decision. So you'll have 0.026 times 1,000 times x plus 7 plus 0.04 times 1,000 times 2x minus 3 and 0.15. I guess I should be using a dot here because I've got x, so that's confusing. Times 1,000 times x plus 1. And so the next step, you should be able to eliminate. So when you multiply 1,000 times 0.026, you'll get 26. When you multiply 0.04 times 1,000, you'll get 40. And when you multiply 0.15 times 1,000, you'll get 150. Which you can do those in your calculator. Okay, so now we have a single variable equation in integers. So what you would do is you'd multiply out all the terms, get rid of the parentheses. I'm going to use my calculator to multiply 7 times 26. So that's 182. Then I'll get 40 times 2, which is 80. 80x. 40 times negative 3 is negative 120. And that's equal to 150 times x. So I get 150x plus 150. 51 times 1. Combine like terms, so I combine the variable terms, and I get 106x. 182 minus 120 is going to be plus 62. Right-hand side already just has separate terms. So I'm going to add the additive inverse of this variable term. I'm going to add the additive inverse of this constant term. You add the two rows, that goes to 0. Here you get negative 44x. You know, if you plug in your calculator, 106 minus 150, you get negative 44. This goes to 0. Then you have 150 minus 62, which is 88. Yeah, I've worked out to a whole number. That's amazing. Then you divide by negative 44. And you get x is equal to negative 2. So again, if you have one that involves decimals, you need to multiply by some multiple of 10. And then you solve it in this form. If you don't do it this way, you're not getting any credit because you didn't listen. Okay, the second section is about word problems. And as far as the word problems like the ones where you add things together to be a total and then you use the other parts, I'm just going to let you look back at the homework problems. The one I'm going to work for you here is the only example that I'm going to show you here, and it doesn't mean this is the only one that's going to be on it, but I'm going to work this one, is the mixture problem. So what I have, I need to make a table, which I'll include the table for you, and you need percent, you need 3 columns, and you need I think 3 rows, but I'm going to put an extra one in there just so I don't. So let's just give you an example. If I mix 5 liters of 8% acid solution unknown amount of 17% solution. I obtain a 14% solution. How much 17% solution did I add? So you put the low concentration solution here. So we have 8% solution. And I'm trying to decide if I need another. Yeah, I think that's right. Okay. So what we have is liters of solution, liters of acid. So we have our 8% solution, we have our higher percent solution, which is the 17% solution, and we result in something in between, 14% solution. So let's see, we have 5 liters of 8%, an unknown amount of 17%, and then liters of 14% solution is going to be 5 plus X. So these are always added together. So I may give you, one of these, and you have to calculate this, or I may give you this, and I have to calculate that. So whatever the unknown amount is where you put X. So 5 plus X is 5 plus X. Then what you do is you calculate the liters of acid, and to do that you take the decimal equivalent of the percent solution times the number of liters of solution. So 5 times 0.08 is 0.4 liters of acid. Just double check. 0.08 times 5, that's 0.4. If I take 17% solution and I multiply by X, I get 0.17X liters. And the resulting is 0.14. So I'm taking 0.17 times that. So I need 0.14 times 5 plus X. So that's just 0.14 times 5 plus X. And to find X, as you add this plus that equals that. So you take these values. So you take 0.4 plus 0.17 times X is equal to 0.14 times 5 plus X. So what we would do is we would get rid of the decimals, and we have 2 decimals, so we multiply by 100. So if you take this, multiply by 100, you'll get 40. If you take this and multiply by 100, you'll get 17. If you multiply this by 0.14, you'll get 14. All the other ones stay the same. And now you solve it. So you get rid of the parentheses. So you get 5, that's 60. 14 times 5 is 60, plus 14 times X. We're going to take the additive inverse of that and the additive inverse of that. We'll take the additive inverse of that and add it over here as well. Then we add the 2 together. You get 0, you get 3x is equal to 20, or x is equal to 20/3 liters. So 20/3 is greater than 5. It's around a little less than 7. And that's because 14 is closer to 17 than to 8. And section 3, we just went over that. Basically, there, you can look at the lecture if you want to. just dealing with proportions and then equations that have used proportions to solve them. So there'll be a couple of those as well, but I'm not going to redo anything. I think what I showed in class is pretty representative of the kinds of things that you could do on the test. So that's it.